Hey, welcome to today's video where I have a new product for y'all. This is the single wire CAN module that I've hinted at in the past that we'll be using for GMLan. If you're not familiar with GMLan, it's a little bit different than your regular two-wire CAN. This one uses a single wire and then ground. That's why there's two connections on the end here. And it has some quirks to it that are a little different than your regular differential CANbus. It has like a high voltage wake up signal where it sends 20 something volts down the line, which can damage regular CAN transceivers. And it runs at 33.33 kilobits, so it's a little bit different than your regular two-wire CAN. One of these modules you can make work with single wire CAN. I've seen posts about it online. I haven't had success doing that, but I am pretty sure that it does work. But yeah, as you can see, my single wire CAN module is significantly different than your regular kind of Arduino CAN module. So yeah, let's take a look at this. We'll get it set up on a little network over here with, we have a instrument cluster, a BCM, and a ECM out of one of these trucks. And yeah, we have all three of these devices because the ECM is on the high-speed CAN, it's a two-wire CAN, and the BCM actually converts that high-speed CAN down to the low-speed CAN for the peripherals like your instrument cluster or your AC and all of that. So you have this kind of, it's kind of a pass-through network happening inside the BCM. So you need the BCM to be able to talk to any of the stuff on the high-speed network, and then yeah, so we'll try to sweep some gauges, we'll capture some stuff, and we'll go into a little detail on the module. We'll definitely have the link for the GitHub where you can get the design files, and then also have a link in the description so you can just buy one of these already built so you don't have to go order boards and parts. So yeah, let's go ahead and get started here and take a look at everything. Okay, so let's first go over the setup. We have our bench power supply with two different power sources coming out, so that way we can take away the power from the ECM and BCM, yet still power the instrument cluster. So we have two of these. We're actually only going to power one right now. I just had two for some other testing that I was doing. So USB connection powers it. It builds its own 12 volts on the board there. We have the ECM, and this is the fuel gauge here, so we just put a potentiometer so we can adjust it and try to capture those frames. And then we have the BCM, and the BCM is going to do a couple of things. It's going to send the command that can turn on and off the instrument cluster with the ignition switch, which we're just using this jumper for. And it also converts the high-speed CAN, which is the two-wire CAN, to the low-speed CAN, which is the single-wire CAN. So this green wire right here is our single-wire CAN, and our high-speed CAN is just out of frame, hooked up to the differential probe. So these wires right here are the connection to the diff probe is just a little out of frame, but it's just right across the high-speed CAN. We have the oscilloscope over there where we can take a look at both the high-speed and low-speed CAN if we want to. And so yeah, that's our setup. So if we want to disconnect power from these, just disconnect this wire right here, and just leave these connected to power the instrument cluster. Ground is tied through this twisted pair here, and yes, these don't really need to be a twisted pair because it is single wire CAN. I just twist them so they don't get tangled. It's already enough of a rat's nest like this. So we can turn it on, and there's a lot of data on there right now. But yeah, so we can adjust the fuel level by turning that potentiometer. As you can see, it's moving a little bit, and then we can also take the ignition off, which will the BCM will tell that to turn off. And yeah, so that's that connection. We can also disconnect the BCM like I mentioned, and then we have just the instrument cluster and no ECM, BCM connected. Okay, so this is the Arduino example code that I will have uploaded on GitHub. And we are reliant on one dependency here that is on GitHub as well. This is the Arduino MCP2515. I've found this library in specific to work better than some of the other Arduino CAN libraries. And so we'll use that library to get us going, use it kind of as the starting point here. We do have the pin modes that we need to set on the transceiver IC. And then that's kind of it for getting it set up. As you know, we're going to use this existing library, which is simple to use. You know, initializing it is as simple as, you know, telling it what the bit rate is and setting it to normal mode, and then we're set up. Receive data function here, we can go to definition of that, and this is how we can read a message. So basically, if we have a message, we can read that data and send it to the serial port. And then for TX, I'm actually just have some manual commands that I'm sending. It's not reading from the serial buffer to send. So TX literally just sends these commands. I found this frame to be the same one that makes it come to life when you put the ignition on there. We have this frame that's going to set the speedometer and the tachometer, and then we have this frame that does the fuel, and I believe this is the keep alive frame that just tells it not to go back to sleep. So this one is a frame that you would kind of need to send relatively regularly to keep the instrument cluster from going back to sleep if you don't have the BCM and ECM connected. All right, so yeah, and we already went over the RX data. So, you know, the functions are pretty simple here. This is kind of the same structure as I did for the J1850 program that is in there. So same kind of command structure to it. And yeah, so we set the pin mode of the transceiver, then we reset the MCP 2515, we initialize it, and then we go from there. So yeah, a lot of this is just handled by that that library that we downloaded. So this library is not one of the ones in Arduino that you can just pull in. So you have to, you know, get the latest zip, and so you just get that released zip, go into, so yeah, you go into Arduino, go to Sketch, go to include library, and then just add zip library. So after you download the library from here. Okay, so we are connected and we want to start reading. So let's go ahead and hit RX. And we're not going to receive anything right now because everything's turned off. So let's go ahead and turn on. This will just turn on the instrument cluster. This will give you kind of a little idea of what the frames look like, because they're much slower when it's just the instrument cluster. So it's basically kind of trying to get everybody to respond. That 62C, I believe, is the one where it's like kind of out looking for everybody else out on the network. So now we can go ahead and it's gonna dump a lot of data. So it's not very easy to sort through this when you do this. All right, so now the everything else should come up here in just a second, and yep, now it's all up, and it's just, you know, too much data. So we can go ahead and just turn that back off. And then the way I worked with it from there is I just started copying, you know, all of this data into like Notepad, and then looking at GMLan Bible, and you start figuring out what the different frames are. So I didn't have to do like I did with the J1850, where I had to like figure it out myself on what everything was. The GMLan Bible pretty much has like everything in it. It may not have all of like the data packets behind it, but it has all the arbitration IDs. That way you can figure out what frames are what. So we'll just take an example from what we just captured and see that we have good data. All right, so our frame we wanted to decode was 9001 C0 40. All right, and that decodes to an arbitration ID of E. So then we can come over to the arbitration IDs over here and see that E is the powertrain immobilizer data. So this right here is our powertrain immobilizer data. So these are all of the data bits here, and this is your header that has the header has that priority arbitration ID and then the sender ID. So that's kind of the breakdown there. So priority, arbitration ID, ECU ID of like who sent it. And so for the most part, what we're going to see here is, since everything's being sent by the BCM, we're just going to see like 40 on the end of every one of these. But we do get some different priorities in here, so we can go ahead and find another one in here to decode. Let's see. Let's look for one that looks like it has some data on it. All right, so this guy's got a little data here, so let's see what he is. So, all right, so 28 is vehicle speed information, which that contains both the tacho and the speedo. So we can come over here and see that breakdown, so vehicle speed information. Since we saw that it had a link button, we know it's in here. When you save it yourself, those links are broken, but if you are still just using the original, the links do work. But yeah, so it says that these 2 bits right here are vehicle speed. These 2 bits are tachometer, and then these 2 are completely unknown, and this one is also completely unknown. So there's the breakdown of it. So yeah, you can use this GMLan Bible to decode a lot of this manually. So we know now that the RX is working. We've proven that RX works because we're getting data that makes sense here. None of these arbitration IDs are completely outlandish. Okay, so now let's transmit. So we have disconnected the body control module and the ECU, and we're in that state that I showed you earlier where it comes up and basically it's just sitting there looking for everybody. If we go to the receive data, we'll see it, kind of trying to find other instruments, but let's transmit data instead. All right, so I sent it that vehicle speed that we discussed earlier, the fuel level, and also told it to respond to commands. Since I did not continuously send that keep alive command, I only sent it that one time. It stayed up for the amount of time that it'll stay up without it, and then it came back down. So we can send that again. So TX, and we can see that it is responding to our commands that we're sending. So we're able to receive, we're able to transmit. So it does all of the things we need it to be able to do. And we're running on a library that already existed. So this project was actually pretty easy to do. The hardest part here was actually getting all 3 things working together so that way we could get it to work. I didn't realize in the beginning that I needed I didn't realize I needed a body control module. I thought that you would get the low speed cam from this. So I ordered this originally and then realized I needed a body control module. So then I found a body control module, and it just took me forever to find the time to wire this all together. So that's what's taken so long for this whole project. I know I'd hinted at this for over a year now that I was going to do it. Well, yeah, here it is. So yeah, we can see all of this set up and running. Okay, so everything you need to actually do something with this is on the GitHub repository for it. So yeah, I'll have the link down in the description. But yeah, if you want to design with this in KiCad, the footprint and symbol are in the repository. If you want to build one of these yourself, this zip file contains all of the Gerbers, so you can send it out to a manufacturer. And then there's the schematic if you need to troubleshoot it. But yeah, so that's everything that's in here. And then in this folder, it has that example code that I was showing you. So yeah, definitely check out the GitHub if you want to get started on doing something with this module. Let's take a look at the schematic and get kind of a better understanding of what's going on here. So the heart of this is just the MCP2515, just like the normal Arduino CAN module. But then we're using a different transceiver chip. So we have the TH8056 from Lexus, and this one's actually specialized in doing that single wire CAN. So yeah, this is made specifically for doing this. So yeah, we have the CAN module, the transceiver, a filter, and then the boost converter that I used in my other design as well for J1850. So same little boost converter to take your 5 volts, make it into roughly 14 volts. And the Lexus runs off of battery voltage. So yeah, it's like anywhere from 6 to, I think it was 18 volts that this pin's rated to. And then we have these 2 modes. So this is different than the regular little CAN modules. Mode 0 and mode 1 said a couple of things. Just refer to the data sheet on these to figure out what exactly you're setting. But yeah, basically mode 0 on and mode 1 off puts it in high speed mode, which will let it do some higher speeds here. And then mode 0, 1, and mode 1 puts it in normal speed, which is for doing the 33.33 kilobits that we're trying to do. It also has like a sleep mode, and then it has another one for transmitting the high voltage wake up signal. So yeah, this is kind of it that I want to go into on the data sheet on here. I guess kind of the detail we need to go into on the transceiver or this chip here. And then yeah, the pinout of the connector, the main body connector here, is exactly the same pinout as the J1850 project. So yeah, the 5 volt, 12 volt, all of those pins are the same. So if you kind of already designed around this and need to do GMLan as well, you already have the footprint necessary. The only difference is that mode 1 and mode 2, they are right here, and they're spaced out far enough that it still fits on a breadboard nicely if you're gonna breadboard this. So yeah, the footprint that I put up for this on GitHub, you can also use it here and then just delete these 2 pins because you don't need them. But yeah, same footprint exactly. So if you're trying to design something for either one of these boards that I did, you can do that. Okay, well that kind of sums up what's going on here in this project, to give you a little overview of how this was tested, showing it working, and then showing how the design works. And then we have the GitHub repository and everything necessary to be able to recreate the project. So definitely, if you like this, check out the link down in the description to buy one on my eBay store. That helps support the channel, helps support doing these projects. It's not exactly cheap buying all of the PCMs and stuff to be able to do this. So yeah, if you like it, you want to support me, you can purchase one of these. I have some other projects up in the eBay store as well. And then the other thing is, this is open source. So if you go to the GitHub and just download the Gerber files and want to go get somebody else to make it, that's fine. You can definitely go that route. It's not like I'm gonna be like, oh, you didn't support me. And then the other thing is don't forget that the footprint's there, so that way if you want to implement this in your design, you can pull that footprint in and use it in your own design. So yeah, I hope you guys like it. I hope you found this useful. And one other thing that I like to say is, if you do use this in one of your projects, I love hearing about it. I really do like seeing other people's projects that implement some of these designs that I came up with and pushed out there into the world. So it's always really cool to see what you guys do with it. So if you do buy one and use it for something, let me know. You know, shoot me an email, show me what you did with it. And yeah, I hope you guys liked the video. It's really all I have for you guys, so I'll see you in the next one.